Good afternoon, Jan.
Michael, good afternoon. Good morning for you.
Very good to see you, sir.
Nice to be back. Nice to be back.
Excellent. Well, the .NET Rocks episode launched, and so I've seen a bit of activity on the Discord. So hopefully we'll get some folks
Mm,
that recently joined.
that would be good.
Mm-hmm.
I I saw the episode of last week,
Mm-hmm.
the .NET episode with I didn't look at it yet, but last week's episode, yes. Um, Nice to have the book
Excellent. Yeah.
coming. That's very good news. It was nice to see you going over the old book with the plans for the new book.
Yeah.
Um,
Yeah. I'm hopeful that I didn't commit to changing too much of it because you know when we wrote the contract, I was
mm,
thinking, yeah, I just need to rewrite one chapter and then touch everything up. So hey, that'll be fine. But but yeah, now that I've gone back through it, it's like, I really want to add an entirely new section. So there might be a rewrite of one chapter and then two additional chapters to cover replicators
mm.
and to really dig into immutable organizations. So yeah,
that would be nice.
might be a lot of work.
That would be nice. But okay, you still have time until January, if I'm not wrong.
Yes, that's correct. January.
But that's going to be fast.
Yeah, it is.
Then, yeah. Then I saw you finished a lot of the work on .NET, um, and you mailed me the new data structures.
Yes, yes. Um, yeah, so I ran into a problem with one of the tests, and then realized that um, the last time that I did a rewrite of the link provider, um, I introduced a bug. So that bug was interfering with the test, and so now I'm going back and doing another refactor on that.
Okay. Yeah, it's getting so complicated that I'm not surprised that there are some bugs from time to time.
Yeah.
Let me see. So I had a little time to continue on the database application. So I did about half of what I wanted to do.
Okay.
But okay, at least that's that's one of two things. But I think I did the easiest part.
That's the right way to start.
Um,
Yes.
yeah. Let me show you that it's this one, I guess. Yeah, it's that one. So the query here.
Mm-hmm.
Um, so the query now, the test, the test is of course not working because the second part is not working, but the first part, yes. So the first part is the binding of the parameters. Um, so if we go to, is it readable like I show it here?
It's a little bit small, but I can kind of make it out. Yeah.
Let me try to. That should be better. Is it?
Yes. Yes, it is.
Um, so this was the test. Can query for successes. Um, yeah, I didn't put a fork up. I think actually the easiest is if we keep it all in your repository,
Okay.
and then
Yeah.
I just make a pull request for the small portion of the SQLite provider.
Okay.
Um,
So I don't know if I've made you a contributor on the repository. So far, we've been working with forks.
on, on .NET, um,
Yeah. Let me just double check that.
I always send you a pull request.
Yeah, yeah. So that would have been a pull request from your own fork. Uh, okay. What I thought you were talking about was if you're a contributor on the core repository, you can create a branch and just work in that branch, and then we can both contribute to that same branch and then merge it back into main.
Um, what is the the easiest and the safest?
I think that's the easiest way
Uh,
to go. Yeah, and there's no danger there because yeah, even if you accidentally commit something to main, yeah, yeah, I'm the only one that can push the button to deploy it to NuGet. Uh, so yeah, let me make sure that I can get that set up. Okay, we're going to settings and we're going to is it security? Oh, collaborators and teams. Yep, and I need to authenticate with GitHub Mobile. Let's see, development, GitHub, authenticate, and it should send me a push. Yeah, uh, I'm doing an authentication, and so that I can set up.
there's a new code. Did you put it on new branch in
Uh,
Jira.net? Because
the
I didn't see.
yeah, so uh, I did the new code in not in the Janaga uh, organization repository, but in my own repository. So basically, I made a fork of your fork, and so that's why I'm thinking that's a little bit complex because I'm trying to send you a pull request so that you could merge it into your repository and
Yeah.
then send me back a pull request with the full thing. And yeah, that's kind of complicated. So I think this would
Because
be easier.
I'm even wondering how much did I send already to my repository and how much of the changes. My connection factory. Because I've been, yeah, that's only a little bit. The SQLite here. Yeah, the bind parameter, that's something I changed now. Oh,
Okay.
but yeah, I
Yes.
wanted to, you see here, 55 outgoing. So most of the things I haven't
Mm.
are still on my computer here because I wanted to clean it up, which I never did.
Mm-hmm.
Yeah. So I think on my fork there is nothing much. But okay, let's check this. Where was I? Okay. So the SQL store test. That was that test that we were doing.
Mm-hmm.
If I run that test, I got last long ago. I generated some SQL, which you did completely now the way it should have been.
Mm-hmm.
But so I didn't change that part yet. So I got a SQL query tree, but that was still my definition.
Ah, right.
So
Okay.
yeah, I didn't change that because otherwise it was quite close to what you proposed. So here or was
Yeah.
that yours?
This one
No,
looks
no.
like mine actually.
Wait. Yeah, these are
Mm.
your copies.
Ah, okay.
Yeah,
I see.
yeah, I may here MLP.
Mm-hmm.
So I copied in this one. No, no. Yours is just the output. And the SQL query tree, that was one that I defined. And you can see it because you have the name SQL query tree inside.
Right. Okay. Yeah. That's because of a difference in how JavaScript works from how .NET works. Yeah.
I did a translation of JavaScript, so that was a structure I came up with.
Mm-hmm.
But so I had the SQL query here. If we look at that, SQL query specification, and so it has SQL, it has parameters,
Mm-hmm.
labels, and bookmarks for the fields. But so all that was old stuff, but I just kept it for the moment because I just needed to get that SQL there to do
Mm-hmm.
the execute query. And so in the execute query, I'm getting two parameters, the SQL and the parameters here.
Mm-hmm.
Yeah.
Makes sense.
So if we go and have a look at that, so compared to last week, actually what I added here was this. So we are running through the parameters,
Mm-hmm.
and we're going to bind them to the SQLite statement.
Yeah. Makes sense.
And that is possible because of a combination of code that I copied from Frank and Eric,
Mm-hmm.
which turned out to be all this here,
Yeah.
which is a little bit more general than we need, but in the
Yep.
end, I kept a lot of things. So the value is actually the value of the parameter that we get in. We check what type it is, and then we bind it
Mm-hmm.
dependent on the type to the SQL statement. The SQL statement, which is actually the SQL expression.
Yes. Yeah.
Yeah. But so that is working fine as far as I can see. But so now,
Very good.
if we run it, we're still having this problem: the row that comes out.
Mm-hmm. Okay. Right.
So that one I didn't solve yet. But then I was wondering if we go back to that the SQL generation document,
Mm-hmm.
this one, there on page 1, 2, 3, 4. No. No, page 6, you have, and then we're talking about this one here. Not sure whether you can read it.
No, I'm
Is it in
afraid not. It's yeah, it's
oh.
pixelating all of the text.
So actually, it's the resulting SQL that comes out of the school and the course specification.
Okay.
And so there we say select f2.hash as hash2, and then the f2.fact ID as ID2,
Mm-hmm.
and f2.data as data2. But so here we just have one output fact.
Mm-hmm.
But in which cases would we have more output facts?
We would have more output facts if we had a select many. So um, it was producing a a tuple. So so if you had your original link had from employee and then from manager, and join back to employee. Then you've got both employee and manager coming out, so there'll be two different facts.
Okay, so we have to call it, for example, #2 or #3.
Yes. Yes, and the fact index is going to be that number 2 or 3.
Yeah. And is that the reason why in the documentation you sent me, if you look to the specification, to the SQL query tree, yeah, the SQL query tree. Wait, let me copy that one in as well. Then it is visible. Let's find that mail. Developing specification SQL query tree. This one. Yeah, just let's put it in here. So that was your SQL query. Oh, I missed.
Let's see.
Yeah. So that was the definition that you sent me.
Okay. Okay, I got it. Yeah, so...
Yeah. And so
yeah.
you have this, so inside you have the SQL string,
Mm-hmm.
you have parameters, but you also have the labels. Yeah, the labels, which are
Yes.
the name, the index, and the type.
Yes.
And actually, when I was looking to your new code, execute query tree in the Jinaga JS version, the server version,
Mm-hmm.
there you actually using this index to do the mapping.
Right, yes, that is correct.
Is that actually the purpose of this specification label?
Yes, yeah, so that index you can use to do the mapping for the output, and then the name and the type are going to be available for processing that row, which I believe I've got the code for that part of it. So yeah, you'll want to use all those indexes in order to map the fact ID, hash, and data.
Okay, because I was wondering before, why do we need that? I still have this this problem that I don't see the fact graph. Yes, but then the SQL in my mind I still don't see the immediately relation between the SQL and the fact graph, and that's terrible. I should play more with it.
That's I think yeah. Let me get to that branch.
In Jinaga server?
In Janaga.net. So I am looking for SQL query. All right, check out SQL query, and let's see if this is going to be helpful. Okay, moving that over there, and let's make sure that stream is capturing what it should. Okay. And then I'm going to share this screen here. Okay. All right, now let's see. Would you mind if you stop sharing, then I should be able to line up the...
Stop streaming. Yeah.
Yeah. Okay. Well, that's not perfect, but you can still kind of see us in the corner. Okay. Yeah. This moving things, moving Discord off to a second window, it's messing with the OBS layout. But here we go. So let's start with the SQL query tree. Yeah, so this is what we were looking at, but the code that I sent you now has some methods inside of SQL query tree in order to do the processing. So you've got the SQL query tree has the SQL query, the child queries. So let's just start from here. So the way that the way that you would handle this is that you've got that particular SQL query that's got the SQL and the parameters and the labels as we just looked at. So we've got name, index, and type. And then you execute those queries. So yeah, you execute the top level query and then recursively iterate through the child queries, and then that executes those and their children and so on. And then while you're walking the tree that way, basically you're building back up another tree, and that is this result set tree. So the result set tree, that has the hash, fact ID, and data. So those three columns that are selected for each one of the tuples, and then
and there we don't care about which fact it is.
Well, we've got here a dictionary of int to result set fact. So yeah, if the indexes that you're looking for are 2, 3, and 4, then you'll have 2, 3, and 4 mapped to their corresponding hash, fact ID, and data.
Okay, the index of that dictionary is that label index.
Yes, that's correct.
Okay.
Yeah, and so you get a list of those because that's one for each row, and then because you're recursing through a tree, then you'll be able to recursively call that function to get the result set tree for the children and build that up. But for right now, you can just start at the top level with a simple query. So once you have the result sets, then you say results to products, and this will go through and merge the child result set. So let's skip forward to that one. So we've got our tree coming in. We've got a product that represents the given, all of the inputs. Product, by the way, is a dictionary of string to element, where an element is either can see the implementations. So it's either a collection or a simple element. So simple element is a specific fact reference. So we're selecting a particular fact. Or collection is a recursively a list of products. So when here we go. So when it starts out, one level more. When it starts out, it's got the product from the givens. So each one of those is a simple element. It's just a reference to that one input fact.
Yeah.
So we've got that product coming in, and the result set tree. So each result set is just hash fact ID and data for each member of the tuple. And then exit early if it's empty. Then we get the identifier and the product of each row. So the identifier is the, you can barely see it there, the list of integers. We can dive into that, see. It's let's go through each label, look up the label's fact ID in that row, and then concatenate all those integers together. So yeah, that's one example of where we're using the label index in order to pick the appropriate element from the row.
Why is that giving more than one integer?
The identifier of the row is the ID of the whole tuple. So in the example where you've got from employee and then from manager, so you're going to get you're going to select two things. It's going to have the employee ID and the manager ID, and so the identity is that pair of employee ID and manager ID.
Okay.
Yeah, there's no guarantee that there's going to be one lowest level fact that can be a stand-in for the identity for the whole row. So I just take all the fact IDs. And then when processing a child result set, then I'm going to be selecting all of those parent facts and then the child facts as well. So I'll take the subset of the IDs, that is the set of parents, and that is how I'll join the child rows back into the parents.
Okay.
So then, so that's how we get the identifier of a row. The product of a row is an aggregate over all of the over the tuple. What is this? Oh yeah, the given product. Yeah, that really should be named product, not tuple. Although I'm not really sure what the distinction is between the two names now. But yeah, so starting with all of the givens, so all the elements for those given fact references. Now I want to go through each of the different labels, pull the that fact. So I've got the hash for that particular fact in that row. Construct the fact reference. So now I'm going back to the type that I have from the label in order to get that fact reference. And then this tuple.with just appends that simple element, that reference to that one fact. So it adds that by the label name. So now the product that I end up with has got the names of all the inputs plus the names of all of the outputs and the fact references of all of those. So far my tuples only contain simple elements, so it's just a flat collection. And that's my identified results. Now I need to fold the child results into those parent results. And so this is where I go through the child's result sets, and I call merge results, child results recursively. So I take all of the all of the child results. So basically, if you've got a query that just has like a top level query, and then inside of the projection it has a child query. So you'll just end up with a tree that has two nodes in it. One that selects all the parents, one that selects all the children. And so this will go through and give you the results of all the children. So each one of those results includes the givens, then the parent IDs, and then the child IDs. So we can take the subset that is just the givens and the parent IDs, and those subsets, yeah, right here is where we do the grouping. So we take just the fact IDs from that from that tuple that are the length of the parent fact IDs, and that represents the parent identifier. So it's walking both of those at the same time. That's the reason for this kind of complicated stuff where it starts at the first one and then it skips the first one and goes to the next. And here, if they're equal, then it adds those child products into the parent. But then if they're not equal, then it moves to the next parent, and then checks that one to see if the child result should go in there. So
it's again a complicated construction.
Yeah, that is kind of complicated, but that allows you to write one query per level of the tree, and then merge them together in memory, versus doing the select n plus 1, where you select all the parents and then use the parents inside of the where clause and do all of the children. So yeah, this lets you do a much more efficient operation. So the part here that I skipped over in order to get to the group. So what this was doing, this products is just a list of products. So it's grouping all of the children that go to the same parent into a list, but it's not yet merging that into the parent. So we just return that collection. So this is where we do that recursive call. We return those child results, and this is where we actually merge them into the parent. So we create a collection element. So far, up to this point, they've all been simple elements, but now we finally have a collection element. Take all these products and put those into the parent. But if we don't have any children with that particular parent's ID, then we give it an empty collection element.
Yep.
So that is basically how that works. Now, because of this whole recursive thing, and it's returning an immutable list of child results, and here we want an immutable list of products. Yeah, this is where we're saying, all right, I expect this child results to just have a single result. So it should end up grouping everything by the givens, and then say, okay, grab all the products for that one group. So that's just that final step. Turn it into what you want. That way, when you call results to products, you now have exactly what the SQL store requires. So let's go back to my store, and when you do the load, you're going to be getting back a fact graph, and the fact graph, well, actually, yeah, there is a little bit more to it. Yeah, here's the SQLite store. Yeah, so you got a fact graph builder. Yeah, there was. I'm missing something. There was a way to get from a product to a fact in order to give it to the fact graph builder. Yeah, actually, I think it's just that a fact is reference fields, predecessors. Yeah, I can't remember what that final step is, but yeah, once you get there, then we can take a look and see how to wrap that up, how to get to that final step.
Okay.
But that'll be close. Okay, I don't know if that helped or not, but that's what we got.
These are things which every time, like the previous session, you also explained the SQL generation. And although I already had translated part of it, it was still very difficult to follow.
Mm-hmm.
And I had to stop the video, go through the code, restart the video, go back a few minutes. It's complicated.
Yeah, it is.
And I still haven't found a way to really document it for myself, because the moment I'm really working in it and I spend a few hours to go back over it, and I say, okay, now that part I understand. A few hours later, I forget it again.
Mm.
But I haven't found a way to document it in such a way that that you just look to the picture and you say, okay, I have it again.
Yeah, I must admit that it's pretty much the same with me. Is that I have to basically reprocess the code. Yeah, the when I'm just working on my own, the tests help me to do that. So yeah, I've got tests around the SQL generation, so I can check to see, given this specification, I generate the correct SQL, and then through the lens of those tests, I can better understand what's happening in the code. But yeah, when walking through the code like this, you've probably noticed I'm trying to remember. Okay, why does this block? Why is this block here, and how does it relate to the fact that we're doing this recursively? So yeah, it is complex stuff.
Yeah, the fact that the data types quite complex with recursive elements in it.
Mm-hmm.
Um, yeah, that doesn't that doesn't make it easier.
No.
Um, but it makes the software a lot more powerful.
Yeah. 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 Yeah.
Um,
I just wanted to. This is the kind of problem that you should only be solved once. Now, yeah, I say that, but then, I have rewritten not just this part, but also like the link processor. That's something that should
mhm.
be just solved once as well. Um, so yeah, I've rewritten them, so I've actually solved them more than once. But at least users of Janaga will not need to solve them themselves. Um,
Because even the SQL generation, um, it will not be a lot different for database to database.
yeah.
Um, for example, now with SQLite, you are using, I think, dollar signs for the parameters.
Mm-hmm.
Well, for SQLite, you have to use question marks. But it's just a small thing.
I looked up the specification on that, and if you use just a standalone question mark, then the parameters have to be in the same order as.
Yeah,
Uh,
but you can use a question mark with a number behind it.
oh,
So
okay. I thought.
question mark one, question mark, just like you do, dollar sign one, dollar sign two.
Okay, I thought I was reading in the specification that you use dollar sign if you're going to use the index. But yeah, um, if it's question mark, then yeah, you can just go through the code and
Where was it?
change the generation.
Let's see whether I find it immediately here. No, I don't have it immediately here. Yeah, I see it. Let me come back to that page. Let's make it a little bit smaller first. Share that one. Which one is it? Yeah, it must be that one.
Okay.
You can see it.
Oh, okay. Yeah. Question N. All right.
Yeah. So
Versus
either
dollar V.
you have a question mark, then it has to be in sequence. Either a question mark with a numerical behind it, and then it follows the order from the index. Yeah.
Mm-hmm.
Either it becomes alphanumeric, and then you just give it a name. It starts with a colon or an ampersand or dollar sign. That's all equal. And in that case, you have to look up. There is a, what is it, parameter find index or something. Yeah, not here. But then you have to look up the index of that parameter name.
Mm-hmm.
But so the best one is to use that one, I think.
Yeah. Yeah, I think
And
so.
that corresponds to the way you did it. The only thing you have to change is the dollar sign. You have to replace it by a question mark.
Okay. Yep, that'll be
But
an easy change.
small things like that. For the moment, I just did a replace
Okay, good.
on the SQL.
Good. Oh,
Because
I
in
mean,
my
after it
original,
generated the SQL. Oh, right. Yeah.
because the way I generated originally was a translation of the JavaScript version.
Mm-hmm.
So I used the dollar sign as well. I say, okay, let's just replace it that way. But so the SQL generator will also be a part that is standard for most of the databases.
Yeah. Yeah. So
Unless
we
you,
yeah we might be able to extract something that's reusable out of it. Um, yeah. For right now, it's I think it's okay for it to be specific to SQLite. Um, I think probably when we do the second one, that's when we'll find what's common, what's different, and how do we best extract.
because the way you did it now, is it different from what you did for for Postgres?
No, not materially. The main difference is the way that JavaScript handles dictionaries versus the way they're handled in .NET. But but yeah, besides that, it's the same algorithm.
Mm-hmm. So that can be just copied to other databases as well, I think.
Yeah, yeah, I think so. Yeah, and I think that the next one for .NET um, is going to be SQL Server, and we'll we'll make it possible to have a .NET um, replicator.
Okay. Um, okay, so where was it here? Yeah, so in the code, what I still, let's go back to that one. So stream, yeah. So if we run that one, let's put a breakpoint in here. Run the
Oh, that's right. I was looking at the wrong one. I was looking at load and trying to figure out what's the last step. Query actually does return a list of products, so we're there.
Okay, yeah,
Yeah.
build errors, of course, because I copied in, wait, I copied in this one,
Uh-huh.
commented out, save it again, debug. And yeah, for the moment, the exponential backoff, I disabled it.
Yeah, I could see how that would mess with debugging.
Yeah, but so if right, let's go to the next step here. There it's easier to see. Okay, so we get to the execute query tree here.
Mm-hmm.
If we look at this one, yeah, just add it to the watch here. Where is my?
Yeah, you know what? In SQLite, we probably don't need exponential backoff at all because it is an embedded database. I needed that in the
Yeah,
replicator because Postgres was another process that might not be running, and so it would have to
yeah.
wait for it to start up.
But remember, in the beginning, we had a lot of problems.
The wall file, yeah, I remember.
Yeah,
Yeah.
and then I think I should look up the documentation, but I think I enabled an automatic retry in SQLite itself,
Mm-hmm.
and then the problem was gone.
Okay.
I documented it
Okay.
somewhere, but
Yes.
I
All right, so let's keep it.
forgot.
It's good.
Yeah, but anyway, you can just exponential backup, false are true, and it does work. But so the SQL query that I generated originally, but so that we will replace by your module then, was that select F2 #2 fact ID and so on.
Mm-hmm.
So with all the parameters, where are they? Yeah, they are behind it there. Yeah, if I copy to another one, you will not see it. Do you see the?
I see it. Yeah. It's if you hit the view, it should give you back a formatted version of it. Yeah. Yeah. Not the down arrow next to it, but view itself is a button.
Okay, here.
Oh. Yeah. It's
So
not showing me the window. That's strange.
wait. Let's do it differently then.
Yeah.
Um,
That was weird.
can I just? Yeah, no, not while I'm debugging. I cannot add anything, I guess. Let's see. It will. I just copy it in. I pasted it in. So for example, here you see the
Yeah.
parameters.
Yeah. Yeah.
Yeah. Okay. Let's do Control V because otherwise he will complain. So that's what we are getting, putting in that execute query.
Mm-hmm.
And here I have my parameters, which are just three. Yeah, he opens again,
Mm-hmm.
which are just three parameters.
Right. Right.
Um,
So there
and
should be
then
the fact type ID, the hash of the input, and then the role ID.
let's put it
So you'll probably see an integer, string, integer.
SQL query. We have SQL parameters here.
Yep. There we go.
See, here we have a hash, probably
Mm-hmm.
a type, and a fact ID. So if we go back to execute query here,
There's the replace. Yep.
yeah. So here we have.
Yeah. We'll fix the generator so that it does the question mark.
Okay, just run up to there. So here I have my statement. There I go to my three parameters,
Mm-hmm.
the second one and the third one. And then he starts giving back results.
Yeah.
And so here he said, not
Mm-hmm.
property not found. And that's because the row,
Mm-hmm.
which is of type T, what I was using now, I was using here.
We have the result set fact from DB. Yeah.
Yeah, from DB.
Mm-hmm.
Why from DB? Because I thought in your definition, result set fact was hash with a capital, fact ID without an underscore, data with a capital. And so it didn't correspond to the name I use in my database.
Right. Yeah, but
I said,
those names don't have the indexes appended to them,
yeah.
and so it's not going to find them. Yeah.
And then I say, why is that not working? And then
Yeah.
I looked up the SQL and I say, okay, yeah, the indexes are not there. So
Yeah.
this is not going to be a solution as well.
Yeah. I think you're going to have to copy that code out of the generic method and instead create a method specifically for the result set facts. And then it'll just concatenate numbers to strings and pull out those specific specific column names.
So actually use the algorithm that you wrote for the server.
Yeah, it would be like that. So yeah, so for each row, then for each label, you've got the fact index, and so you grab hash of fact index, fact ID of fact index, data of fact index, put that together into a result set fact, and then iterate, put those into a list.
It's fun code, combination of a map and a reduce.
Yeah, hey, it's amazing how often that combination comes up. We should give that pattern a name.
Yeah, every time I see some link, I think of you. I seldom see people who are using links so often and so combined as in your code.
Yeah, that's that's one of the things that I'm a little bit concerned about with the adoption of Janaga.net is, I'm used to putting together link statements that mean a full specification, and this might be new to a lot of people. So yeah, that's a skill they'll have to learn in order to generate a specification that's useful in Janaga.
Look, and I will not be the only one, okay?
Oh yeah.
I had a lot of trouble with it in the beginning, but now it's starting to go. But okay. I think it just depends. Programmers who use it every day, they should have no problem with it at all. Programmers are used to all the technologies. yeah,
Mm-hmm.
they they will have to catch up.
Yeah. Yeah, that'll probably be my first use of AI on the site. Would be, um, hey, give me a model, give me a prompt that describes what you want from this model, and then have the AI generate the link. I mean, I've seen that work
Okay.
in GitHub Copilot, and it usually gets it spot on. Um, so
Mm.
yeah, just upload that to Janaka.com, and then that will be a little tool for people to, okay, wait a minute, how do I do this? All right, copy that, paste it into my code, keep going, and then eventually you'll you'll pick up the patterns.
Yeah, that will perhaps be a great help in the beginning. In the new book, do you intend to explain all this code as well, or the
Um, I don't want
just
to make it a
because you
Janaka.net reference manual, but
Mhm.
yeah, but I do want to get into some detail about how to use an immutable runtime. So I'll be kind of walking that line.
Okay, because you were talking also about an intermediate language. You had the old yeah, you have the specification language.
Mm-hmm.
You had what was this called, the old language,
The factual modeling language.
factual
Yeah.
language, but you want to have a language in between.
Yeah.
Um,
Yeah. So I think that uh, so one of the things about the Janaga specification language is that being for Janaga, it understands that all of the data types, all of the facts are based on JSON. So
yeah.
the data types of the fields are just your JavaScript core types. So some of that leaks into the specification language a little bit, but yeah, the more I think about it, the less I think that that's really a problem, because if you were just writing pseudocode, then you would pretty much be sticking to to strings and numbers and booleans.
Mhm.
Um, the distinction between integer and floating point number is not going to be really important in pseudocode, and there is no distinction in JavaScript, um, and so there's no distinction in Jnaga. And dates are the weird one. The fact that uh, dates are converted into strings in JSON,
Mhm.
that becomes quite apparent while you're using Jnaga, especially when you're recording facts. Um, so so that might cause some difference in the specification language, but yeah. So the factual modeling language is intended to be really human readable um, and close to sort of a mathematical description. So
Mhm.
it's 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 got the kind of the terms of mathematics, but I don't use the symbols because I want people that are unfamiliar with that with those symbols to be able to read it and understand it pretty quickly. But in the Janaga specification language, I use symbols, but they're not math symbols; they're programming symbols.
Mhm.
Um, so uh, So yeah, I'm not quite sure if I want to have a human readable version of the Janaga specification language, and then basically that's an evolution of the factual modeling language, or if I just say, yeah, it's the Janaga specification language. So read these, understand these while you're just describing models to people, and even your business analysts and your UX designers um, that are describing how the user interface works will be using this specification language. And it just so happens you could also copy this, paste it into Postman, and run it against a replicator and see the results. Um, so yeah, having one language does have an advantage. I just
Because
don't want it to be too close to Janaga. Yeah.
because if we already have the link expressions, we have the specification language. If now we add a third one, um, or a fourth, because
Yeah, because in JavaScript you've got a different
Yeah.
language because you don't have LINQ.
Right. In the end, it becomes so many languages.
Mm-hmm.
Um, I would not complicate it too much.
Yeah. 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 So that's starting to sound like the right choice is to start using the Janaga specification language instead of factual throughout the
Mhm.
book.
Okay.
Yeah, I
Um,
just won't call it that right at the beginning, and then it'll be at the end when you're saying, "Here's how to use an immutable runtime," and oh yeah, that same language that you've been learning, that's what it speaks.
because I think if people get used to it, um, they should be able to understand it.
Mm-hmm. Yeah, and you can prove theorems in it. It's amazing. I love that part.
Yeah. Um, so I will continue on that little portion in the query to make it integratable
Mm-hmm.
to that what was it? We got as input the SQL query tree, and we got as output the result set tree.
Yep. Yep.
Okay.
Exactly.
Um,
Yeah, and you do have write permissions on the Janaga.net repository, so you can create a new branch within that repository,
okay.
and that'll allow us to
Um,
collaborate on that one branch.
yeah. And the code you wrote for the SQL generator, you put it in already or not?
I have not yet, but yeah. So
Yeah, but otherwise for the testing, what I can do for the moment, the code I made, I can copy it in temporary.
mm-hmm.
With that, I can continue to test my portion, and once your portion is ready to copy in, it will just replace it.
Okay.
And perhaps we just have to modify the data types a little bit, but
Okay. So yeah, I will push my branch to the Janaga.net repository, and then when you're ready to do that, you can merge my branch in, and
yeah.
then you can yeah, you can get rid of the code that you copied from the email and use that merge instead. Yep.
Mm-hmm. All right, let's do it. Let's do
Excellent.
it that way.
Yeah.
Okay.
Much easier than this pull request on top of pull request thing.
Mm. Okay. Okay, Michael, thank you very much, and
Thank you,
see you
Jan.
next week
Yes, indeed.
with .NET working.
Yes. Yep. All ready
Hopefully,
to ship.
if
Just
I get so far.
yeah, publish it to
Okay.
NuGet. All right.
See you.